To begin our study of chemistry and our journey into the world of atoms and molecules and compounds and elements, we want to learn about what matter is. We want to be able to describe matter. Now, matter is not energy. Energy, as it says here, is the ability to do work. And there are lots of different kinds of energy: electrical, chemical, mechanical, etc. Matter is not energy. Matter is anything that has mass and volume. It takes up space. If it has mass and volume, mass and it takes up space, then it can be classified as matter. And we can describe it by its properties. Now, there are two types of properties that we can describe matter. We can use to describe matter: physical properties and chemical properties. Physical properties, as it says here, we can observe without changing the identity or the composition of the substance. For instance, if I tell somebody that and look at them and tell them their shirt is blue, I haven't changed the identity of that shirt in any way by telling them that the color is blue. If I take the temperature of a glass of water, I haven't changed the water in any way by determining its temperature. If I look at a balloon and say that the substance inside that balloon is a gas, I haven't changed the identity of the material in any way by telling anyone that it's a solid, a liquid, or a gas, what its state of matter is. The mass, if I weigh something, if I determine its mass, I did not change its identity. So those are very obvious physical properties, but two that people sometimes miss whenever it comes to determining whether something's a physical or chemical property are density and solubility. Density is simply the mass of an object per unit volume. How much mass a particular substance has in a certain amount of space. But I don't have to change the identity of that material to determine what its density is. All I have to do is weigh it and figure out how big its volume is. And we've already established that figuring out the mass of a substance does not change its identity. And measuring how big that substance is, the size of it, it's not going to change its identity either. So density is a physical property. You don't change the density simply by saying that a piece of styrofoam is less dense than a piece of lead. Solubility as well. If I'm trying to figure out the solubility of a substance, I'm usually trying to dissolve it in water. There are other substances that you can dissolve chemicals in, but usually it's water. And so all I have to do is to put some salt in the water or put some sugar in the water, and I can determine its solubility. And at first you might think, well, yeah, you change the composition because it disappears. But does it really disappear? If you taste the water, now granted, I'm not going to have you taste anything in the lab, but if you were to taste the water, would you still find the same properties that you noticed before for both sugar and salt before you dissolved it in the water? And the answer is yes. The sugar would still taste sweet. The salt would still taste, yes, salty. So you haven't changed the identity by dissolving it in water. All you've done is move the particles so far apart from each other that you can't see them anymore. The water gets in the way. We could get rid of the water. We could evaporate the water off, and if we did, we would recover the sugar and the salt at the bottom of the container unchanged. So we don't change the identity by determining its solubility. That's also a physical property. Chemical properties, on the other hand, and I have to admit those are pretty much my favorite, chemical properties do change the identity of the substance that you're testing. For instance, if you're determining that something is flammable and you burn it, I'm pretty darn sure that you're going to change the identity of the substance in the process of burning it. Reacting it with acid or any other chemical is going to change the identity. Exploding, checking to see if that substance is explosive or not, is definitely going to change the identity of the substance if you manage to blow it up. So those are some examples of chemical properties, and anytime you have anything that has the word reactivity in front of it, you know it's going to be a chemical property. It's going to react. And other examples of physical properties, probably ones that you want to write down. If it involves the senses in any way, whether it's the smell, taste, how it feels, definitely what it looks like. We're a very visual species, and we tend to make our observations be visual. But all those other senses, if we can smell it, taste it, feel it, hear it, those are physical properties. So anything that involves the senses is a physical property. So when you do that worksheet over these properties of matter, one of the things that you're going to do is to put a check beside each property as to whether it's physical or chemical. And simply use these guidelines in order to make that determination. Now, the other thing you're going to have to do is to make a check to decide whether it's either intensive or an extensive property. Extensive, I think, are some of the easier ones to do because there are so few extensive properties compared to intensive properties. Extensive properties are the ones that change if you change the amount of material you have. I use the X to remember that if you cut it, chop it up, you change it. For instance, if you chop a piece of wood in half and you study just half of that piece of wood, it's going to change its length, it's going to change its mass, its volume, its weight. All of those are going to change. If it changes when you cut it in two, it's an extensive property. On the other hand, if you cut something in two and the property does not change, it's intensive, it's internal, it's inherited. It doesn't change when you start cutting that up into pieces. For instance, if I cut a piece of styrofoam in two, it doesn't change its density. It's still going to float on water. And if I cut a piece of lead into 10 pieces, those pieces are still going to sink in water. Changing the size does not change the density. It doesn't change the color, nor the odor, the taste, how soluble it is, the boiling point, freezing point, reactivity. None of those things change just because you make it smaller. So those are intensive properties. And that's the other thing you'll have to do, again, on the worksheet, is to make checks in the appropriate box for whether it's intensive or extensive. So each property should have two checks, one for the type of whether it's physical or chemical, and one for whether it's intensive or extensive. Now, as far as the states of matter are concerned, there are three major states of matter. Yes, if you look into some of the scientific literature, some sources will say there are 4 states of matter, and that plasma is one of them. Others will say that there are 5. Some will say that there are 9 different states of matter, but that gets into areas of chemistry that are a little bit beyond where we are right now. We'll pick some of those up later, but not for right now. Right now I'm going to stick with solid, liquid, and gas. And when we look at the states of matter and look at their properties, solids, we can talk about whether they have a definite shape or not, whether they have a definite volume or not, and how they move. Solids have a definite shape. They have a definite volume that you can measure. So you can draw their shape, you can measure their volume. Almost wrote shape twice. So definite shape, definite volume. And as far as how they move, the particles vibrate only. They don't move from place to place. They are rigidly stuck in one place and they simply vibrate. Liquids, on the other hand, you ought to pause this for a minute and come up with whether liquids have a definite shape and volume or not, and whether gases have a definite shape or volume, and see if you get those right as we go on through them. So hopefully you came up with the fact that a liquid does not have a definite shape. There is no definite shape for a liquid. But could you measure a liquid? If you've ever cooked or did any baking and it said go get 1 cup of milk or 2 cups of water, you know that you can measure the volume. It does have a definite volume. As far as its particles, the particles move fairly freely, but they have boundaries. They kind of slide around each other is the way some sources describe it. Fairly freely, but in boundaries. If I pour a glass of water out on a table, you'll be able to draw the boundary of where that liquid reached. It does have boundaries. A gas, hopefully you came up with the fact that a gas has no definite shape. And no definite volume. Also the fact that the particles of a gas move very fast and at random. They're just zooming around every place and they're pretty far apart. You'll also find that a gas is the only state of matter that is easily compressible. You can compress it down fairly easily into a smaller volume. So those are some characteristics of solids, liquids, and gases, and you have an activity in your packet that's going to deal with that as well. Now, as far as the phase changes are concerned, these are going to be important when we start talking about physical and chemical changes later. Vaporization is the transformation of matter from a liquid to a gas. There are two types of vaporization. Vaporization that occurs just at the surface of a liquid is called evaporation. If it occurs all the way through the liquid, then you're dealing with boiling. Evaporation and boiling are different from each other. Melting is when we have the transition from solid to a liquid. And I would stop this and see how many of the rest of these that you could get before we fill them in together. Hopefully you got that freezing is going from a liquid to a solid. That condensation is going from a gas to a liquid. That sublimation, the last two you may not be nearly as familiar with, but sublimation is probably my favorite phase change because one of my favorite chemicals does this. I love dry ice and I love doing different kinds of things with dry ice. So dry ice sublimes. It does not have a liquid state under these conditions of temperature and pressure. It goes straight from a solid to a gas. Why it's called dry ice. It doesn't go through a liquid phase. Deposition is the opposite of that. Again, one you may not have heard before, but that's when something goes straight from a gas to a solid without passing through the liquid state. Not very many substances do that either. So those are the different phase changes. And finally, when you're making observations of the properties of matter, there are two types of observations that can be made, and there's a worksheet that deals with this in your packet as well. When you have observations that deal with descriptions, just describing the material, not making any measurements or anything, just talking about what maybe the material looks like or feels like, sounds like, smells like, etc., we're dealing with qualitative observations. The quality of the material, qualitative observations. On the other hand, if we are measuring something and we come up with a number, if there is a number value, we are dealing with a quantitative observation. Quantity. So in general, you can pretty much make the determination that if there are no numbers, it's qualitative. If there are numbers involved because there are measurements, then it's a quantitative observation. So stop this real quick and pause it and just see if you can come up with which is which on these next two descriptions. The grass is 10 centimeters tall. The grass is green. Based on those observations, what type of observation are they? Hopefully you came up with the grass as 10 centimeters tall, since it's a number value, is quantitative. And the grass is green, since that's simply a description with no numbers or measurements involved, is qualitative. So we have a couple of worksheets now that you can do out of the packet.